I think this will be mostly straightforward. These are just like the addition ones. Start by rewriting it. And then, obviously you have the same denominator. So that means that you can put both of these together. So on the left side, I'll deal with the first fraction, 3x plus 4. But, this whole guy would be in parentheses over here. And I can keep track of this without making a mistake, but for this first problem, I will write minus and leave it in parentheses, x minus 1. I don't expect you to show that as a step unless you like it. And the reason you might be inclined to show it as a step is that it'll really discourage the likelihood that you'll forget to distribute this negative here and make that an opposite sign. And then we just have to combine like terms, and we'll have 3x minus x is 2x. 4 and 1 gives me 5 over x minus 2. And as we look at this, there's no factor to pull out, and there's nothing that can cancel, so that's totally done. Problem 2, super similar. That should be a 2. It is a 2, it just doesn't look like a 2. 3m minus 5 over m plus 4. Minus 4m plus 2. And then that's also over m plus 4. And this whole section is about the fact that they have the common denominator. You can put them both together over the same fraction. And in this time, I will not bother putting that in parentheses. I'm going to subtract 4m, but make sure I subtract whatever that is over the other side, so that positive becomes a minus. 3m minus 4m is negative m. Negative 5 minus 2 is negative 7 over m plus 4. And sometimes you'll factor out a negative just so that you end up having positive variables. I think either way is totally acceptable, but if you look in the back of the book, or if you look on Wolfram Alpha and you see something different, that would be the explanation why. Okay, problem 3 can be totally an OYO problem, and I will throw the work up there in just a moment. Okay, so I'll slowly scroll through this, and it really doesn't matter where you make this change, but at some point you'll definitely factor out a 5 to simplify this problem. Now, I'll do just one of these, I think. Now, look at these denominators. This says m minus 9, while the other one says 9 minus m. But they're super crazy similar. So we'll rewrite problem 1, 2m over m minus 9, plus 4m over 9 minus m. Now, I definitely prefer to see this left fraction. And the reason is because I like dealing with positive in front of the variable. It's definitely less challenging that way. But this whole 9 minus m deal, I want that to become, basically its opposite, m minus 9. And the only way I can do that is by factoring out a negative. So I'm just going to do it my way, which is to change the sign. And as I look at the denominator, nothing crazy is going to happen. And I'll make sure those flip. Now keep in mind, if this was a negative 9 minus m, you wouldn't be able to do this. That would end up not making it match up. So we'll show these as steps. I probably would be inclined to just jump down here and be like negative 2m. But since we're learning this, I'll write 2m minus 4m over m minus 9. And then I'll have negative 2m over m minus 9. And that problem's done. I am of the opinion that you're fine with these, so I'm going to show just the answers to these in about 10 seconds, to both of them. So make these both on your own. Here are both the answers. The only weird thing about problem 3 is that you're done there. You might be tempted to want something to cancel out, but the t squared minus 3 does look like a perfect square, and it is, but you would have to factor it out as t plus the square root of 3 times t minus the square root of 3. and neither of these would cancel out with t minus 3, so you're done there. Okay. That's kind of the case of, like, you see so many problems that are super similar, and then one gets a little bit off the beaten path, and it feels different. This is your homework assignment for 11.6. Let me see how many other distracting, random things I can put on this screen as I ramble on. Enjoy. Have fun. Believe in yourself.